BenchIE FL, a manually re-annotated fact-based open information extraction benchmark. This paper introduces BenchIE FL, a new open information extraction (OI) benchmark designed to improve upon the existing BenchIE. BenchIE FL aims to provide a more accurate and reliable evaluation of OI systems by correcting errors, inconsistencies, and limitations in the annotation and matching functions of BenchIE. The authors also present a comprehensive review of previous OI systems and benchmarks, highlighting their strengths and weaknesses. The development of OI systems has evolved from rule-based models such as Reverb, Clause-IE, and Mini, to neural models like Emoji-IE, M2O-IE, OpenIE6, and Compact-IE. These systems are trained on bootstrapped data from earlier extractors, with varying degrees of success. The authors discuss the creation of OI benchmarks, including OIE 2016, Wire57, CARB, and BenchIE. Each of these benchmarks has its own set of annotation principles, text corpora, and matching functions, leading to varying conclusions about the best performing extractors. The paper highlights the limitations of BenchIE, such as missing facts, incorrect annotations, and inconsistencies in the matching function, which can lead to biased results. To address these issues, the authors propose BenchIE FL, a re-annotated version of BenchIE. BenchIE FL uses new guidelines for sentence annotation and tuple matching, resulting in more concise, precise, and pertinent annotations. The new benchmark also includes a more flexible matching function that captures more valid extractions, providing a fairer ranking of evaluated systems. In addition, the authors compare 7 OI extractors and demonstrate that believed state-of-the-art systems are not necessarily the best when evaluated on BenchIE FL. They also show that the scores of extractors on BenchIE FL exhibit a much stronger correlation with their performance on 3 downstream tasks. The authors categorize error types in OI annotations into 5 types: missing fact, false fact, irrelevant fact, double annotation, and double meaning. These errors are prevalent in existing OI benchmarks and necessitate more thorough annotation guidelines. The authors annotated facts output by various OI systems and found many cases where a system made a valid extraction that did not match an annotated fact. This led to the development of a new matching function to capture more matches between extracted and annotated tuples. The authors propose annotation guidelines for OI output, including principles such as informativity, minimality, exhaustivity, relation completeness, and inference. These principles aim to ensure that annotated facts are informative, minimal, exhaustive, and relationally complete, and that inferred tuples are included when implied by the sentence. The guidelines are motivated by the need for solid principles in OI annotation, which are often lacking in existing benchmarks. Examples illustrating these principles are provided, showcasing how they should be applied in annotation. The authors argue that existing benchmarks, such as BenchIE, do not adequately capture these principles, leading to errors and inconsistencies in annotation. The proposed guidelines aim to provide a more comprehensive and accurate approach to OI annotation, which is essential for downstream tasks such as question answering and knowledge base population. Moreover, the authors discuss the need for matching guidelines to determine which extracted tuples should match with which annotated clusters. They propose principles to guide this process, including the need for exact matches and nuances such as allowing for optional words and capturing implied information. Examples of these principles are provided, and the author's full matching guidelines can be found in an appendix. The research paper introduces BenchIE FL, a re-annotated version of the BenchIE corpus, focusing on enhancing the quality and specificity of open information extraction (OI) benchmarks. New guidelines emphasize relation specificity, word choice, and level of detail to ensure precise and comprehensive annotations. A validation experiment demonstrates that BenchIE FL annotations adhere more closely to the guidelines, with fewer errors compared to BenchIE. A new matching function for evaluating OI systems is also developed, capturing more matches than the exact matching used in BenchIE. This function includes alternative formulations, level of detail matching, and punctuation heuristics, addressing issues related to word choice, level of detail, and punctuation in annotations. The F1 score comparison on BenchIE FL shows that the exact match function is outperformed by the new heuristics, aligning better with the guidelines. The authors present a comprehensive evaluation of OI systems, showcasing the effectiveness of BenchIE FL in reflecting real-world performance. They evaluate 7 OI extractors on 3 downstream tasks: assertion-based question answering, complex questions answering with quasi-knowledge graphs, and knowledge-based population. The results demonstrate that BenchIE FL's rankings closely follow the rankings obtained by evaluating OI extractions in these downstream tasks, highlighting its effectiveness as a benchmark. A correlation analysis is conducted to compare the rankings of OI systems across different benchmarks, including Wire57, CARB, BenchIE, and BenchIE FL. The results show that BenchIE FL exhibits the highest correlation with downstream task rankings, indicating its ability to reflect real-world performance. Significant differences are observed in system rankings between benchmarks, with recent state-of-the-art benchmarks, such as BenchIE and CARB, overestimating the performance of neural models. The authors conclude by highlighting the contributions of their work and suggesting avenues for future work, including the annotation of additional sentences and the exploration of new OI approaches. The paper presents BenchIE FL, a novel framework for evaluating open information extraction (OI) systems. It addresses limitations in existing benchmarks by providing a comprehensive evaluation platform assessing OI systems across accuracy, completeness, and their ability to extract information from diverse linguistic constructions. A new annotation scheme categorizes extractions as correct or incorrect based on relevance, and a custom matching function measures similarity between system outputs and gold annotations, outperforming exact matching functions. The framework includes a dataset of 300 annotated sentences, offering a more diverse and challenging testbed. Evaluation results show BenchIE FL can differentiate between state-of-the-art OI systems more effectively than existing benchmarks. The paper discusses limitations, including its small size and English-only availability, suggesting future work in increasing the dataset size and extending it to other languages. It also details the implementation of various systems and benchmarks, highlighting the use of systems like Reverb and OpenIE 6, and benchmarks Wire57 and CARB, with a focus on the technical aspects of their implementations and performances. The internal frame backpack, invented in 1967 by Greg Lowe, serves as a metaphor for the importance of accurate scoring methods in neural system scores. In the CQA task, a modification to the scoring method led to lower scores compared to the original paper due to the regrouping of entity formulations into distinct answers, computing MRR on those answers for a more accurate evaluation. In the KBP task, annotations from KnowledgeNet were compared to those from BenchIE using objective proxies to identify differences and potential errors. The results showed that BenchIE's annotations contained more errors, with examples presented in Table 19. The re-annotation of the first 100 passage question pairs of web assertions following the BenchIE format demonstrated the importance of accurate annotation, with the new scoring method providing a more accurate evaluation. The evaluation of various proxies for annotating facts in text highlights the significance of double annotation in identifying errors. The authors verify that most cases from BenchIE are double annotation errors, whereas BenchIE FL shows a higher accuracy. The double meaning proxy reveals a high count of errors in BenchIE, while the false, irrelevant, missing facts proxy shows an inversion in counts, indicating the author's annotation is more exhaustive. The paper emphasizes the need for a comprehensive annotation approach, incorporating inference and adhering to the minimality principle. The author's annotation is shown to be more accurate, with fewer irrelevant formulations of facts. The significance of accurate fact annotation is highlighted for better understanding and utilization of text data. The research focuses on evaluating various information extraction systems, including Reverb, ClauseIE, Mini, Emoji, OpenIE 6, M2OIE, and CompactIE, to identify their strengths and weaknesses in extracting relevant information from natural language sentences. The authors present BenchIE and BenchIE FL, two annotation systems for evaluating information extraction performance, which annotate sentences with relevant information such as entity relationships and event extractions. The annotation clusters in Table 21 demonstrate the different ways in which the annotation systems extract information from a sentence about the release of My Classical Way on September 21, 2010, on Mark's own label, Frazzy Frog Music. The annotation guidelines presented in the appendix dictate which facts should and should not be annotated for the open information extraction task, emphasizing principles such as the number of arguments, informativeness, minimality, exhaustivity, relation completeness, and CO reference resolution. These principles are demonstrated through examples, showcasing how sentences should be annotated, including those that should not be included, to ensure the quality and relevance of the extracted information. The concept of inference is crucial in open information extraction, OI, distinguishing between light and heavy inference. Light inference requires no logical reflection, whereas heavy inference necessitates reflection or external knowledge. The paper provides examples to illustrate this distinction. It also discusses reformulation, active and passive voice, attribution, and speculation. Furthermore, it outlines the matching guidelines for the open information extraction task, emphasizing principles for exact match, relation specificity, and other aspects of matching extractions. The paper highlights the importance of considering errors, word choice variations, and the level of detail in matching extractions. It emphasizes the need for extractions to convey the same information as the annotations. Adding a single level of detail is acceptable, but combining information from more than 3 annotated clusters is considered too noisy. The summary concludes by emphasizing the significance of precise matching guidelines for accurate OI.